Ariana, how are you? You hear me?
Yeah.
Okay, let's get started, okay? Okay, so last time we talked about data. We talk about data type first, and then we talk about data compression to compress to a smaller file, right? And we talk about lossy compression and lossless compression. Today, we are going to look at data analysis and data information. Okay, we'll look into that. So data starting from you have a physical world. So for example, you actually take a SAT exam. So when you take SAT exam, you bubble your scorecard. So your scorecard is at least you have A, B, C, D, E, and you bubble it. Okay, you bubble it. So you bubble something, and then the reader read into AC, for example, a pick two problem, it pick AC. So this is your raw data. When you scan in your car scorecard, this one is your data type, and it's actually represented in string format. So from here to here, you use a scanner, and then you actually read the scanner and then recognize it as a data, and data represented in string, integer, floating point, or Boolean value. But that's your data, and this data we call it raw data. Raw data means it's unprocessed. So from this unprocessed A, B, C, D, whatever you answered, they check with the correct answer, and then they give you a SAT score of that's as soon as 1350. So this score 1350 is a cook data, COOK, cook data. Compared to raw, it's the raw beef, and this one's cooked beef. Okay, it's actually already been processed. So your unprocessed data is A, B, C, D, whatever the score, the number that you entered, or the data that you entered from your scorecard that you bubble it. Then it become the data of SAT 1300. So that's become a information. So cooked data can also be called as information, and they use this information to make decision. For example, you apply to college, they use your GPA versus your SAT, and then certain region of the score. So you higher certain, and then certain SAT higher than certain GPA, you got the meeting. So that actually is a decision. So it's from information you make decision, then that actually is the whole process of the data processing. Okay, so that's actually this chapter, you need to know what is data science. Data science is from the birth of your data to the death of your data, the whole life cycle for data. From the data is created to data is presented as a result. That's the whole thing is called data science. Is that okay?
Yeah.
And the birth of the data, you can also call it data source. And then the death is data sink, where you end. Just like your water has some source, water has water sink. It's starting from water source, you have a this one, you actually flow water out, and then you raise a sink. You sink the water to the sink, to sewer line. Okay, so it actually this one, the whole thing is called data science. And then that's actually the data science. The life cycle of the data is called data science. The science about data is called data science. Then the next term that you need to learn is big data. So big data is a ideal for data science, because if you just take one SAT, then you have 1350. then you really don't know how good this student is, because this student may school at that time, maybe overperform that time. Maybe next time he only had 1,200. Maybe he actually next time has 1,600. We don't know. So only one score is very difficult to determine whether this student is good. But if this student takes 3 tests, 1350, 1410, and 1290, so we can know that this student's boundary actually is from here to here, around this range. So more data means you can make better decision. From one score, I cannot know that whether you work hard or not. But if you continue to test for 10 times and give me all the score that you scored in the 10 times, I can make better decision of who you are or what you are sure of. Is that okay?
Yeah.
So for example, that if we want to know what, say you go to the Amazon, let's assume that you go to Amazon. So you go to Amazon, and then Amazon has a lot of, let's look at chips, right? So there's so many kind of chips, but which chips sell the best? Actually, in the back end, Amazon know that this one may be sold out for 500 units, this 100 units, this 10 units. So they know that which one sell better, right? So if they continue to collect 10 days, they know about which one sells good or bad. If they collect 1,000 days, the data is better. If they continue to do 3 years or 10 years to collect the data, then the data is even more accurate to know about which is more popular item. You know what I'm saying?
Yeah.
So big data is good. Bigger data is good. You give them bigger data, you make better decision. So one thing is that big data is also good data. So you try to collect as many data as possible and try to make those data good data as well. Okay, that's the whole purpose of the data. So then, because you want to collect the data from beginning to the end, so you need to do processing of the data, cleansing the data, processing the data, and then data visualization to present the data, and then build a database and data model. Okay, these are a few terms that you need to learn about data. Okay, so that's the whole purpose of this chapter, is to knowing about what is data, what is data science, what is the process of the data. Okay, and then that's actually is the introduction for data science. So right here, when you're physical world, you score the bubbles of the SAT score, then you collect your raw data. Your raw data maybe is A, B, C, D, whatever. And then you need to clean the data, because sometimes you bubble, but the bubble is not solid. Then you may need to read the second time. So you may scan for the first time, but you get A, X, B, C, D, because this is actually not able to be written, because it's actually partially bubbled. So you need to recheck the scorecard to see if that is a B or not a B. You need to make sure of that. That's called cleansing of the data. Is okay?
Yeah.
So this process of the data is like scanning the bubbles. So from bubbles to A, B, C, D, that actually is the process of the data, the early process of the data, to sense the data, to scan the data, and then you clean it. After you clean it, you know what answer it is. So you know it actually is A, B, C, D. And then you actually compare with the correct score, A, B, D, C, E. So you have 2 wrong. So you know that this is 2 wrong. You put into the machine learning model and put into the database. So then after that, you actually collect, as soon as you collect 2,000 students, those 2,000 students SAT scores starting from 1,100 to 1,580, and then the student distribution is like that. You collect over 2,000 students, so you know that the distribution is like that. Okay, then you build a machine learning model for that, and then you decided that, okay, let's do this. Higher than 1,400, we admit it to San Jose State. So that's actually this part we admit. That part is making decision. So you make decision based on the model, and then you represent the report. Represent the report means that you actually show people SAT 1,100 to 1,150. These are 50 people, and then 1,150 to 1,200. These are 120 people. 1,200 to 1,250. These are 300 people, whatever, continue to do that. So you will get the so-called barcode, the bar chart. You get a bar chart for each different one, and then you make decision. Okay, this one is called data visualization, how you make your data representable in bar chart. Is that okay?
Yeah.
So in Python, you remember that in Python, we already teach you the whole process of how to get the data, how to process it, how to present it, how to make decision. In Python coding, we already teach you that, right? Remember that? Yeah. You remember that?
Yeah.
This chart you still need to remember, okay? In APCHP, you need to know about the whole process of the data science. This chart you need to remember well, okay? So next one is big data. Big data is the broader term of the data set, so that a complex, large complex traditional data processing is inadequate. So you want to collect more data, okay? So one example is the prediction made by Gordon Moore. He said that the computing power of the computer chip will double every 1.5 year to 2 year. So that means he come up with this Moore's law in 1955. And so far, this law still exists because, let me see, the semiconductor, the computing power is growing in the way that he predict. So he make a model of the double for every 1.5 years. So your growth model is like this, and it grow like this since 1965 to until now. Recently, the computing power keep growing, so AI become possible. Okay, that's called Moore's law. Is that okay? Moore's law. It's presented by Gordon Moore. Gordon Moore is the founder of the Intel. Is that okay?
Yeah.
Okay, now next one, let's look at this video. Big data is good data. Something wrong with the voice. Let me tune it, okay? Okay, this is so close. Okay, let's go further.
America's favorite pie is Apple. Of course it is. How do we know it? Because of data. You look at supermarket sales.
Okay,
30 centimeters.
the first thing that he said that the most popular pie in United States is apple pie, and how we know it. You are based on data, so you need to collect the sales of all of the supermarket to make this decision. So here we talk about big data, and then he was talk about what's the importance of big data. Okay.
Your pies that are frozen, and Apple wins. No contest. The majority of the sales are Apple. But then supermarkets started selling smaller, 11 centimeter pies, and suddenly Apple fell to like 4th or 5th place. Why? What happened? Okay, think about it. When you buy a 30 centimeter pie, the whole family has to agree, and Apple is everyone's second favorite. But when you buy an individual 11 centimeter pie, you can buy the one that you want. You can get your first choice. You have more data. You can see something that you couldn't see when you only had smaller amounts of it. Now, the point here is that.
Okay, so what he said right here, we can learn something is like, when you buy a 30 centimeter pie, the whole family can only have one choice. So very likely that actually nobody like it, but the second best choice, like Apple, will be chosen because what? Because you have to agree with somebody else. Too many people make the decision. The whole family have 5 people, 10 people, right? So you actually end up, maybe usually you just pick the second choice, but the most popular one is Apple. But when you go down to a smaller size, then everyone can pick his own pie. Then at that time, pie best number one choice will be different from Apple. Okay. So that is actually the power of the data. And we talk about bigger pie, smaller pie. That means that when you do market survey, when you do market research, what kind of pie should I sell more? Is that an apple pie or pecan pie? It's based on your survey result. So you need to collect the data and knowing that what pie is the most popular. But big pie and small pie, the most popular item may not be the same. Is okay?
Yeah.
But we use those big data to make business decisions. For example, if you are the Safeway manager, store manager, or the whole chain store manager, you need to make decision on what to keep in the menu and what should not keep in the. For example, you are McDonald's chain store manager. You need to determine whether should I make a more McChicken or more fillet or fish. You have to have some data to back it up. Okay, that's called big data. Okay, that's called big data.
Data doesn't just let us see more of the same thing we were looking at. More data allows us to see new. It allows us to see better. It allows us to see different. In this case, it allows us to see what America's favorite pie is, not Apple. Now, you probably all have heard the term big data. In fact, you're probably sick of hearing the term big data. It is true that there is a lot of hype around the term, and that is very unfortunate because big data is an extremely important tool by which society is going to advance. In the past, we used to look at small data and think about what it would mean to try to understand the world. And now we have a lot more of it, more than we ever could before. What we find is that when we have a large body of data, we can fundamentally do things that we couldn't do when we only had smaller amounts. Big data is important, and big data is new. And when you think about it, the only way this planet is going to deal with its global challenges, to feed people, supply them with medical care, supply them with energy, electricity, and to make sure they're not burnt to a crisp because of global warming, is because of the effective use of data. So what is new about big data? What is the big deal? Well, to answer that question, let's think about what information looked like, physically looked like in the past. Okay, in 1908, on the island of Crete, archaeologists discovered a clay disc. They dated it from 2000 BC, so it's 4,000 years old. Now, there's inscriptions on this disc, but we actually don't know its history. But
somebody discovered this 4,000 old disc. and then they put a lot of symbol in there. So they kind of recording data. So this is a piece of the data. Maybe we don't know if this is 1 byte. So this probably around 100 bytes of the data being recorded. Okay, so that's the art that 4,000 years ago, that's continue to see.
Is that this is what information used to look like 4,000 years ago. This is how society stored and transmitted information. Now, society hasn't advanced all that much. We still store information on disks, but now we can store a lot more information, more than ever before. Searching it is easier. Copying it
Okay,
is
so
easier.
now we store the
Sharing it.
data in the hard disk. So we still put it on the disk, but this one is way more dense.
It's
Okay.
easier. Processing it is easier. And what we can do is we can reuse this information for uses that we never even imagined when we first collected the data. In this respect, the data has gone from a stock to a flow, from something that is stationary and static to something that is fluid and dynamic. There is
This part
liquidity.
is said that it's actually from static, because originally you have a disk, so you cannot change it, no change. You can only read it, and the size may be only 100 byte. And right now you're using the hard disk, and the hard disk may be 2 terabyte, and you can get the information, store it back, get the information, store it back using program to process it. So because you can change the data, and then you can copy, you can send email, you can send to everywhere. So the data is more fluid, like water can flow to somewhere else. Initially, it's actually static. You cannot send it because it's a disk. You have to carry the disk. Very hard to carry. But now it's actually electronic format. So you can send it, you can store it, you can compress it. There are many things that you can do. It's more fluid, like water. Okay.
Information. The disk that was discovered off of Crete, that's 4,000 years old, is heavy. It doesn't store a lot of information, and that information is unchangeable. By contrast, all of the files that Edward Snowden took from the National Security Agency in the United States fits on a memory stick the size of a fingernail, and it can be shared at the speed of light. More data, more. Now, one reason why we have so much data in the world today is we are collecting things that we've always collected information on. But another reason why is we're taking things that have always been informational, but have never been rendered into a data format, and we are putting it into data. Think, for example, the question of location. Take, for example, Martin Luther. If we wanted to know in the 1500s where Martin Luther was, we would have to follow him at all times, maybe with a feathery quill and an inkwell, and record it. But now think about what it looks like today. You know that somewhere, probably in a telecommunications carrier's database, there is a spreadsheet, or at least a database entry, that records your information of where you've been at all times. If you have a cell phone, and that cell phone has GPS, but even if it doesn't have GPS, it can record your information. In this respect, location has been datafied. Now think, for example, of the issue of posture, the way that you are all sitting right now, the way that you sit, the way that you sit, the way that you sit, it's all different. And it's a function of your leg length and your back and the contours of your back. And if I were to put sensors, maybe 100 sensors into all of your chairs right now, I could create an index that's fairly unique to you, sort of like a fingerprint, but it's not your finger. So what could we do with this? Researchers in Tokyo are using it as a potential anti-theft device in cars. The idea is that the carjacker sits behind the wheel, tries to stream off, but the car recognizes that a non-approved driver is behind the wheel, and maybe the engine just stops unless you type in a password into the dashboard to say, hey, I have authorization to drive. Great. What if every single car in Europe had this technology in it? What could we do then? Maybe if we aggregated the data, maybe we could identify telltale signs that best predict that a car accident is going to take place in the next 5 seconds. And then what we'll have datafied is driver fatigue. And service would be when the car senses that the person slumps into that position, automatically knows, hey, send an internal alarm.
Okay, so collecting our data when you have a car, you may have a collision, you may be stolen. They are sense. You have a sensor, you have camera, you will actually detect it, and they will collect the data and they will alarm, send out alarm. So these are data science as well. Okay, that's what he say. So right here, he finished the basic discussion of what is data and what is data science, and he's trying to give more examples. So we may cut short a little bit here. We may hear more, but we may cut short and then we'll jump to other topic. Okay.
Break the steering wheel, honk inside to say, hey, wake up, pay more attention to the road. These are the sorts of things we can do when we datify more aspects of our lives. So what is the value of big data? Well, think about it. You have more information. You can do things that you couldn't do before.
Okay, so this one probably is around 1960s. Around the year of 1960, the whole thing right here is one computer. Okay, they have data input unit, they have the keyboard processing for input, they have their CPU maybe. Okay, they have their graphic processor, whatever, but the whole building is one computer. And the whole building's computing power may be less than right now is one cell phone. Okay, but electronics keep improving, the computing power keep improving. They can store more data in smaller spaces, so it keep moving. So we are in the age of getting the data to be smaller and more compact and then more
The
powerful.
most impressive areas where this concept is taking place is in the area of machine learning. Okay, machine learning is a branch of artificial intelligence, which itself is a branch of computer science. The general idea is that instead of instructing a computer what to do, we're going to simply throw data at the problem and tell the computer to figure it out for itself. And it'll help you understand it by seeing its origins. Okay. In the 1950s, a computer scientist at IBM named Arthur Samuel liked to play checkers. So he wrote a computer program so he could play against the computer. He played, he won. He played, he won. He played, he won. Because the computer only knew what a legal move was. Arthur Samuel knew something else.
Okay, so he said that early 1950s, a person write a maybe chess program or any game that a human play with a computer. Then he play, he won, he play, he won, he won. Because at that time, computer have very little data, little machine learning, very little AI possible. But nowadays, I don't think human can compete with computer anymore because this actually is much, much bigger in the data size, in the machine learning, in the AI category. Okay, so the AI really benefit from the bigger data. Okay, whatever. So now we will discontinue right here. Okay, we basically learning what is data, what is big data, what is the trend of the big data, and why we need big data. Okay, that's actually where the talk is. You can continue when you actually after the class. Okay, I'll copy the link for you. Okay, I'll copy the link for you, and then we will look at other other aspect. Okay. So that's about the big data. And then you need to learn about the big data process. Okay, and big data, why we need big data and what is the historical reason for big data that we know. Now, there are two more terms. One is called big data, one's called cloud computing. So big data means that you collect a lot of data for machine learning for many purposes. So we know that. So what is cloud computing then? Liana, what is cloud computing?
Um,
Do you know?
no.
You don't know? So you do have a computer, you have a Macintosh, you have a PC, okay, at your home. This one we call it client side. But client side cannot do too much computing power because a lot of things the local computer is not so strong. So in the far data center for Google, they build a super computer. Sometimes we call it CPU farm, or we call it data farm. So the computer is super huge. And then you try to, this one we call it the server side. So this one is client side, this part is the server side. You have a server. So you keep asking the server to do computing for you and get the data. This is called cloud computing. Is that okay so far?
Yeah.
So cloud computing means that you actually collect the data at the remote side, at the data center side, and they build a super big data server. Okay, that's search the internet. So let's search data farm. So when you search data farm, you do see a tons of the cabinet of computer like this. This is a data center. So it's not a single computer. It's not a desktop computer. It's not a notebook computer you build. Every computer rack may be 10 to the power 5 times bigger than your PC, and it's put into the cabinet format. And then the whole data center is a huge data center. Okay. And then AI, let's assume that you know about the OpenAI data center. OpenAI also build a super big data center, and the whole data center will consume the same power as the whole San Francisco city. Is that okay? They build a super big data center and put a lot of computer, tons of the computer over there. And every single one is a cabinet of AI processor board, GPU, a lot of them. They connect a lot of wire together to do computing. So that's the where the data center is for the AI. That's user called cloud computing. So your local computer cannot store enough data to process, but a center side can do, okay? Center side can do. And because of the nanometer technology for a semiconductor, the computing power keep growing, so they can build bigger media chip for the AI purpose. Okay, so these are the trend of the AI, and this tell you your semiconductor transistor from 10 nanometer down to 2 nanometer is getting smaller and smaller. So each IC chip actually put more transistor in there when they get smaller. Okay, so these are the IC manufacturing technology. Okay, so these are where you need to know what is big data, and so big data is a broad term of data set. So you collect tons of the data, okay, and then those tons of data you use it for processing to get a more better decision. Okay. So let's look at the one example for data science is the Uber data science. So Uber data science, have you write Uber before? Have you take a Uber taxi before? Hello? Have you take a Uber before?
No.
No, you never. So let's assume that you actually standing on certain streets, cross street, and at this point you are here. Let's assume you are here, and then you try to call Uber. You use your cell phone to call Uber for service, and they will come with a few car, candidate car. Those are cars around you, and they will pick the cheapest one for you, or the shortest time to you car. The car come to you in the shortest time. So they use a certain algorithm to find it. So maybe let's assume that this one will come to your location. Okay. So this one is based on data science because they need to collect the data for the map and also collect the data for where the car is and also collect the data of where you are and use these different information to calculate which car is the one come to pick you up. It's okay?
Yeah.
That's also data science. That's also big data. Okay, that's also big data because they analyze the traffic time based on the past information. So big data is collecting more data of where someone go from one point to the other, and then they will know that how much time they will travel based on the past information. So big data science and machine learning is basically using the past information to collect data to make decisions. Okay, those are what data science, big data is. Okay. So now you collect the SAT scorecards bubbles, that's called raw data, and you process it into SAT score that we call it the information. And based on the information, you say that the GPA greater than 3.5 and SAT greater than 1500. These people actually are usually will be more successful in college. So we will admit them. So this become a knowledge of uh, uh, picking of the students. So you say SAT plus GPA times 800. These are used for the San Jose State. They use a GPA times 800 plus SAT to determine whether you are admitted or you are actually rejected. So those dual, we call it a knowledge. So data is the bubble. Information is the raw score. You have SAT 1500. And using the equation of the GPA times 800 plus SAT, that is called knowledge. And what is wisdom? Wisdom is AI. So AI may change. So this year we are using GPA times 800 plus SAT. Next year we may use a GPA times 1000 plus SAT. Okay, and then next year we may use a GPA times 1000 plus mathematical GPA, only calculate mathematical GPA times 500 plus SAT. So the equation keep changing, but which we pick a better equation to admit the more adequate student or more capable student, that is wisdom. That's your intelligence. Is okay so far?
Yeah.
Okay, so when you have a car, let's assume you drive a Tesla. You drive a Tesla, so this is a Tesla car, okay? So this is a Tesla car. So Tesla has a lot of sensors. They sense where the collision should be. So they have camera here. And then they build a model knowing that you are on the road and then you are here and then there's a car over here. You may have to avoid the collision with it. So this kind of information is processed from your sensors data to the roadmap model that you build information. And based on those information, you make decision of passing it or parking on the side or back up. You actually make a lot of use those information to do the decision. Then that's called knowledge. And then the wisdom is that you come out with the Tesla AI5 chip. Then next year they become AI6 chip. So they improving their AI engine, keep doing that. Those require wisdom because they pick a new formula, more token model. Is that okay so far?
Yeah.
You need to know about these, okay? You need to know about these. So server farm, we talk about it, is the data server farm. Farm is a data center. So they put this data center in the remote site, maybe somewhere in New Mexico, maybe somewhere in Arizona, somewhere in the desert, somewhere nobody live in, to put a lot of computer there to serve for you. That's called server farm. Okay, let's call server farm. Okay, it's actually called data center. So usually data center is like this. They have many cabinet. Each one of this one, either this we call it CPU blade. One CPU blade usually bigger than your desktop computer, bigger than your notebook. Only one piece like this. And then they have tons of them as a center. So their computing power is way bigger than what you know. Okay, that's when your computer become bigger, your program still work. It's called scalability. This will be tested in AP. Okay, you must know. When you say scale, means that your N become bigger, your number of processor become bigger, your number of the data become bigger, the problem become bigger. We call it scalable. Okay, if you can still process the data, we call it scalability. And usually, it look at the metadata to know about what to process. Okay, what to process. So metadata is data about data. So for example, you have a JPEG image. They tell you that this file is 200 pixel by 100 pixel. Okay, and then this is JPEG format. So this type of the information, we call it metadata. As for the picture that you are in, those are real data. That's not metadata. That's real data. The picture you have, that's your real data. And then the data about data is your metadata. Let's talk about this file is this big, or this file is in this format. Those are metadata. Okay. Okay. Remember the metadata. What metadata should be. Okay. In the exam problem, you will see that. So we talk about what is data science. Now we're going to talk about the first step, collecting data. So collecting data, you can use a scanner, use the microphone, you can use a scanner, you can use a keyboard that actually is also the way that you collect data. You can put out a survey phone and scan it in. Okay, those are a lot of ways that you can do it. But everything we call it survey. You use the Google survey to survey for your data. Okay, so you can create a Google form to create a class questionnaire. Okay, you can still do that right now. Okay, you actually can go to the Google site and you can create a form. You just say Google form, So you can sign in Google Phone. And then you can create, let's create this one, a template. I do create some phone before here, right? So right here, you can create a phone. You want to sign up for a t-shirt. So the medium size, color, whatever you want to pick. Okay, and then you preview it. Is that okay? This is a phone.
Yeah.
So this one is a Google survey. We call it Google Phone. And then everybody sign up this one, putting their number in, their size of the data, and you process it. Okay, but right here, this is the first step, collecting data. Is okay?
Yeah.
Collecting data, after the collecting data, your data may be wrong because there are some people, okay, for example, they forget to enter their size. That's one problem. Second problem is that here you should put Eric Chow, but for some reason, this guy just spell ERI and then CHO. The last letter miss out. So the data is wrong because you don't have the right name. So when this happen, what should you do? When your data misses something, what should you do? At the end, when some data miss out, or he fill the form in the wrong way, what should you do? Hello? Hear me?
Like fill in the gaps.
The data can never be used because it's dead data. So you delete the file and ask the person to re-enter again. Is that okay?
Yeah.
Because the data is wrong name, wrong size. That's not the data you want to have. You corrupt your data. Okay, so that's the first thing. You need to clean it, process it and clean it. Okay, clean the data. This part is very simple. Okay, this one is not hard. We will go through it a little bit quicker. So we go to this questionnaire, we collect data, and then we clean the data. Okay, so modify the wrong field, fill in those missing parts. Okay, and then data set may be biased for some reason. Okay, because sometimes, for example, you only put the choice of AP, CSP. What is your favorite subject? But you only pick AP, CP, and CSA. And there is no calculus, there is no physics. So you can only pick among this and this. And then those data can be biased. Okay. Can be biased. Data set may be biased. If your phone not designing well, your questionnaire is not designing well, they may have a lot of bias on your data. And those data may need to be cleaned, may need to be deleted, depending on how serious the bias is. Okay. Okay, the next one is called data mining. Okay, now this term data mining. So you build a database, you actually clean it and put them into storage. So you create data set. So a data set is just your Excel file, your name versus SAT score. Okay, name versus SAT score. So you put a lot of these are the data set. Okay. Then that's a data set. And a few data set, we call it a database. Okay, the whole school SAT score, the whole school GPA, the whole school's physical PE's score, the whole thing, we call it database. Single data set is like SAT score. Now, there's a term called data mining. Okay. Liana, what that mining really means? What does mining means?
Like finding patterns in data.
Finding valuable information from data. So the original term for mining is, let's look at the internet. So gold mining, you try to dig out gold. Okay, you try to dig out gold from gold mine. So it may be a mountain, it may be a mountain range, and you actually try to dig out the gold from here. But when you dig it out, what do you get? You get 90% of the stone, 5% of the copper, and maybe only 1% real gold. But you are trying to purify the gold, so eventually this is what you get 300 ounces of the gold, maybe from 2,000 tons of the gold mine dirt. Okay, the whole thing, you dig a lot of dirt out and then try to process it and purify it to 300 ounces of the gold. This whole process, we call it mining. Is okay? We call it, this whole process, we call it mining. From digging out the information to process it to get the valuable item, that we call it mining. So right here, let's assume that you actually, let's see, you want to know top 1% SAT scholar. So you actually, this year, the whole College Board collecting 1.6 million of the student test. So they collect a lot of bubble card, ABCD, 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 a lot of bubble. Okay, they collect the data sheet, and then they process into many SAT score. And then this many SAT score, they put into the distribution, and then they determine the cutoff 1% is 1560. And then this is the information that they process and get out. So the whole thing, starting from scorecard to processing to getting the real useful information, we really just need to know about one number. That number tell me what is the top 1% SAT score. Then this whole process, we call it data mining. Is that okay?
Yeah.
So the data mining is just like gold mining. It means you collect data, process data, okay, cleaning data, cleansing the data, and then purify the data, making sure that you actually keep those information that you needed, and then eventually present the data. The whole presentation, I just need to know SAT 6000 is the top 1% SAT score. So this year is 1560, maybe next year is 1570. It depends, okay? So every time the data change, your final result may be different. And the whole process of collecting the data, processing the data, and then purify the data, and then make useful information from the data, we call it data mining. Is that okay? Hello?
Yeah.
Okay, then next one, we have the search tool. Search tool, you keep searching the internet. For example, you search in the internet for so many times, and then Google know that how many people search this. So there is a website called Google Trend. So Google Trend is a website, And then that's actually is for SAT versus ACT. Let's do SAT only. So when you do this Google Trend for SAT, that means that interest over the time, the past 24 hours, how many people search for SAT? So you can change the time. Let's put it like starting from 2004 to now. These are the people where people search for SAT. Let's add another one. Let's add ACT. So this is show you that people who search internet, are they more interested in ACT or are they more interested in SAT? Hello? Are you okay?
ACT.
More people search for ACT for sure because ACT is way above of the SAT. So when they do searching, more people search for SAT. Okay, let's do another thing. Okay, let's don't do these two things. Recently, gold and silver are so popular. Let's search for gold versus. Okay, these are the interest for searching the gold. Searching gold versus searching silver. Okay, you do see that people are more interested in gold, but recently the interest of the silver pick up. You see that?
Yeah.
So this one tell me what? What do you learn from here? What do you look at this chart? What do you learn from here? This is data analysis. You get to data, the search interest for silver and gold, and then when you see there's a peak for silver to pick up, what do you learn from this signal? That means more investment interest on silver now, so buy silver. Does that make sense?
Yeah.
Let's do another thing. Let's do another comparison. Let's do Google stock versus Amazon stock. Okay, you see these two things. So for a certain time, Amazon stock are more popular. For a certain time, Google stock is more popular. So that means, well, in terms of popularity, we are talking about who search more on internet. So for this Google trend, we can analyze recently Amazon stock is more popular than Google stock because more people are asking for it. But the most recent trend may be Google pick up here, okay, because Amazon dropped down. So those are things that you know, or you will help you to make decision in investment. Does that make sense?
Yeah.
So before you do anything, trending is very important. You know about where the trend is. Like your GPA is growing or it is actually your GPA is actually going down. Then the college know that this student is working hard or is actually he is losing steams. He will know based on the trending. Trending means that you learn past information to determine the future performance. Is that okay?
Yeah.
That's called trending. Okay, so I explain what is trending, what is the Google Trends site, okay? And then you need to filter the data as well. Okay, so we know about the basic of the data science. Next one, we are going to talk about transformation. So your data starting from a bubble to the SAT score, this is one transform. From your SAT to SAT plus GPA data, that's actually another transform. So your data from collection, you do keep transforming it, okay, modify it, improving the quality of the data, okay, those kind of things. Making chart, okay. These are data transformations, okay. Okay, these are what data science is, okay. So in the AppLab, in the code.org AppLab, there's a one column, tell you one column data. Okay, so one column data, then you have two column data, okay, and then you make a chart, okay. In Python, we talked about it already. Next one, Google Trend, you need to know about the trending tool. You need to know about digital divide, okay. So this term is very important. You may every year test 2 problems to 3 problems in multiple choice. For what is digital divide? Digital divide means that economically, socially inequality regarding to the access and use of and impact of information and communication technology. That means some area, for example, LA downtown, the black people do not have enough computer. That's called inequality, okay? Or some area like in maybe Nevada, certain community, okay? They are primitive Indian, American Indians living there. They have very low economic, they don't have money, they cannot buy computer. So they do not have the access to computer, they do not use computer. So this kind of the social instability, inequality or economical instability, poor people, less educated people, okay? For example, Asians usually is not, because Asian family usually give you better education. White people usually get better education. Hispanic people usually get worse education. Black people get worse education. And then women get worse education, okay? Those kind of inequality in society and economy limit the people who can use the computer. We call it digital divide. Okay. Okay. So the end, digital divide is getting bigger or getting smaller. Is the digital divide getting bigger or getting smaller?
Getting bigger.
Getting bigger because US rich people grow their money like this. Poor people grow their money like this. They keep using their money. So the gap between them, the money gap is bigger, 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 bigger. And then the rich people give away their money to their children, so their children continue to grow. And then the poor people, they actually don't have money, and they actually don't pass down too much money to their kids. So this the divide, digital divide keep become bigger and bigger, bigger and bigger. That's why college admission recently had the DEI policy. Okay. Okay. So it actually is to improve, try to narrow the gap. Okay, but it's very hard. So digital divide keep expanding, and more people got affected. More rich people get more rich. Poor people get more poor. Okay, that's the problem. So there are still a lot of area in US do not have computer. Okay, you know how many people taking have their high school over APCS course? So if you search internet, it said approximately 48% of the public high school offer AP computer science. That means more than half, 52% of the high school do not offer APCP or APCSA. But this data is based on 2021. I think right now already past 50%. Maybe right now it's actually higher percentage. Is that okay? But this data is given in 2021 and 2022 year. Is that okay?
Yeah.
So you are lucky that you go to a high school that offer the APCSP, APCSA, because a lot of public school they do not offer, they don't have the APCSA or APCSP. So these student in a way they don't learn computer in their high school. So when they go to college, they don't know the computer knowledge. They kind of cannot compete with students who come from more high-tech area, like Bay Area student. They are more advantaged with the knowledge of use of the computer. So this is also part of the digital divide. Is that okay so far?
Yeah.
Okay, so next one is data visualization. You make the data visible, okay, to compare the share price for some stock, okay? So do trending and then to show them, okay? Okay, we continue. So the next one is when you try to build your database and do analysis, you may need to use a database tools. You may need to have a data center. You may have the scoreboard. You may have the dashboard for people to enter the data, and you actually provide the growth rate, target price, a lot of things. So this whole thing is your technology, okay? We really use Python, we are building this, but our example is small, but the whole thing is to present the data, to collect the data, to process the data, okay? That's the whole thing that we want to learn for the data science. Okay, and then data science, you do funding, you get money, and you do have a motivation trying to, let's assume that we want to sell a t-shirt. So you know you need to design a phone to ask for the t-shirt's size and the color that they prefer. And then you design the project and you collect the data. Okay, we got an order of 500 purple M size, 200 of the purple small size. So you collect the data and you start to manufacture loads of t-shirt for people. Is that okay? And then eventually you distribute it. That's the whole data set science project. Does that make sense?
Yeah.
So these are different steps for data science. Okay, these are the different steps for data science. You need to remember them. Okay, this chart. Okay, right here we already compared the Google trend for you, so we don't repeat. Okay, Google trend. Bottom line is that for data science, most important part is you want to tell a story. You want to tell a story. For example, if you have a GPA times 800 plus SAT, this is San Jose State's admission criteria. Then you say this one whole number greater than 1300, you got admitted to CS department. That's the whole story you want to tell. What score you will admit them into a college. this part is to tell a story. That's the whole purpose of the data science. Okay. Let's assume that your school want to select a few students as the honor society student, honor student. Okay. So you want to select honor student, then you must set up the criteria. So Liana, what do you mean by honor student, outstanding student? What's in your mind is an outstanding student?
Like at least 3.5 GPA.
Okay, 3.5 GPA, and what else?
Like taking AP or
Okay, let's
honors
assume that
classes.
6 or more APs. Okay, what else?
Like being of your class.
Okay, anyway, you are providing the benchmark already. You are already providing, let's don't talk about sort of criteria. We would say initially you need to tell a story. The story is number one, academically super. Number two, so let's assume the top 1%. And then second, that is actually great analytical performance. Okay, let's assume that you actually win state medal or better record. Okay. Third one, dedicate on community service. Okay, let's assume these are 3 stories that school would like to see for a honor student. These are stories. Based on those stories, that's actually, we want to pick top 1%. So the GPA of 3.9 plus will be our school's 1%. Other school may be 3.5. Some school may be 3.7. We don't know. But based on the data we have from our school, we need to pick top 1%. Is that okay?
Yeah.
Okay, next one, analytical performance. You need to get some medal. So we determine that the state top A for school event, for example, swimming or track and field. Okay, those are events that actually the school have the team, varsity team. Then we pick the state top 8. Okay, and then if it is actually some events that school don't offer, for example, like archery, then we only pick state top 4. So this kind of criteria is used to pick which student is an honor student. But before you come up with such criteria, you should have a story. Next one, community service. If you service more than 1,000 hours up before the end of the junior year, then we consider you are honor student. So these are different criteria, and we will admit different students to honor society. But before we set up these different rules, we need to have a story. The story is academically outperform other people, or you have great analytical performance, or you have a high community service record. Is that okay?
Yeah.
And the number you provide is actually a criteria to pick, yeah, but those are to changing every year. Okay, so the first thing you must tell a story first. Does that make sense?
Yeah.
Okay. And then you need to know about how to present your data. Okay, so and then collecting the data, and then organize the data, put it into file, and then you do analysis, distribution, whatever. Okay, and then you show your data. Okay, so this actually is a process. Okay, these are the process for the data science. We have many more charts, but it's okay. And you know what is teacher divide, okay? And let's watch out the time. Make sure we cover everything, okay? Okay, so these are the data science. We are moving on to the next topic. So data science is collecting data, processing the data, and then making decision, right? But what is AI? AI means that you want to interpret the data. Okay, let's look at the interpretation of data now, okay?
Students, welcome to data analysis and interpretation. So now that most of you have gone out and started to collect your data, let's see what the next phase will probably look like. The purpose of this lecture is to start making some sense of the data that you've collected. This is to see how your intervention went and how it performed. Then the next part, once you get it all together, is you analyze it. So the analysis helps you answer some of the questions that you were talking about the whole time as you were developing your program, which is, has the program made a difference? And then also how big was
Okay, one thing is that you learn Python or JavaScript. This part we call it computer science because you learn coding. Okay, and then this is supporting your data science. Data science is the collecting the data, cleaning the data, putting it into learning model, and then present it and then make decision. This is whole thing is called data science. So your CS is supporting your data science. Okay, and part of the data science is called machine learning. And then machine learning and whole thing representing AI. Does that make sense?
Yeah.
So, Liana, why do you study APCSP? Why do you want to study APCSP? Why do you want to pick this course and want to study? And what do you expect to learn from this course?
Coding helps in like a lot of jobs.
How can coding help a lot of jobs?
You can organize like data.
Yeah, so basically, you learn APCSB because you have a CS built data science built upon data the CS, so you know how to do coding, but the coding really is to support your data science activity. And your data science activity help you to study biomedical problem. For example, if in the future you become a doctor or you become a researcher in medical field, you will need to know how many people got affected by COVID-19 and how many of them using certain medicine and then that got cured, and how many people they use the medicine but they still pass away. This kind of thing need the data science analysis. And for example, eventually you come out with the idea of Moderna, the so-called vaccine has a 90% protection ratio, and AG have 75% protecting ratio. These are based on data science. And you learn this APCSP because you want to learn CS and data science in order to support your future biology study. Does that make sense?
Yeah.
Just like you learn math. Why do you learn math? Or why do you learn English? Not because that eventually you will use math or English to make a living. No, maybe not. But because you will use the math and English to support your study in your professional field. Is that okay so far?
Yeah.
I would say that would be the purpose that we discussed right here, okay? Everything starts with purpose.
Whether it was in attitudes, behavior, or even the knowledge that you changed. Steps in this process. So when we talk about data, there's a couple of steps that I'd like to bring your attention to keep in mind is organizing it. So how are you going to store it? Where are you going to keep it? Because that makes it easy for you to start preparing the data so that you can start describing it. Then when you describe the data, kind of like just seeing what you got, looking at what you got, you start to interpret. And this is what's going to be really cool because when you're writing your objectives and when you were creating your pre-test post-test, that's what you were doing to help you assess and evaluate your process, assess and evaluate the change that you were going to make. So when we talk about quantitative data, that talks about specifically like the number sign, in other words, any degree of change that has taken place. This is more number-based. And then allows an assessment to be made about the consistency of the data. Talk about qualitative data. So with qualitative data, this here is important because it helps you look at common patterns. This is also important because it's used in forums where you're collecting information, like when you did your interviews. So there's not a real number thing that you can do there all the time.
When you collecting the data there, one kind of data is called qualitative data. Another kind is called quantitative data. Okay, so quantitative data like SAT score, right, 1500, that actually have number. That's called quantitative data. Qualitative data means like, okay, how do you feel the service of the McDonald's? Okay, from 0 to 10. So somebody bubble 10, somebody bubble 5. But these are quantitative, but actually this just means good, very good, super good. Okay, there's not really a scale that actually is well formulated. Okay, 0 to 10, it just means poor, very poor, up to good and very good, great. You know what I'm saying? So those kind of data, we look at it as the good or bad. Those kind of data, we call it as a qualitative data. Okay, you like it or you don't like it. It's good or bad. Okay, those kind of things qualitative data. Quantitative data is actually your blood pressure, your eyesight viewing capability. Those are things that you can put a single number to describe it. That's called quantitative data. But you do data science, you will collect qualitative data, you will also collect quantitative data. Is that okay? Hello, is that okay?
Yeah.
So qualitative data usually stored in string. Quantitative data stored in integer and real number. Does that make sense? Because this is sometimes word, okay? Okay, whatever. I'm sorry. Continue.
Sometimes people will just give you kind of opinions and what they think and what they feel. Can't really put a quantitative value to that. So that's called qualitative data. And I want to introduce the notion of theme analysis. So theme analysis is essentially what qualitative data is. A theme analysis is when you look through qualitative data, so all the quotes, kind of like when you do your end of semester evaluation, we ask that you give us some feedback, and it's like open space where you type things up. We look for theme analysis, and I'll have some examples of this. There we go. So an example is, for example, like Tim 3, you would ask, include any additional comments regarding the lectures. And if you see the 3 bullets, this is showing very raw results. It's, just what people said. 1, very knowledgeable, but hard to follow. This is with regards to lecture. Expert in the field, but not delivering material effectively. as well as no doubt, very knowledgeable, but dry delivery. So the next step would be to analyze and interpret this. So you're looking at it, you see the theme. So going back to theme analysis, the theme is, it does seem that this person is knowledgeable. That does not seem to be a problem in terms of content. An area of improvement would be in the delivery. So that would be something to keep in mind. Now that you've kind of looked at it this way, the next step would be to interpret your data, then asking the question, so why is this so?
Okay, so you organize the data, you get the data. Next one would be to analyze the data. Okay. Let's continue.
Results from your pre and post test project questionnaires. So things to keep in mind, how many individuals responded. This is what we call the N, which I'm sure you're familiar with. And just as you're looking at everything, putting everything in a table, probably doesn't make a lot of sense yet, but you're just looking at everything that's called the raw data. Here are some examples of how some people may collect demographics. So you'll see they're just, put in all the different race or ethnic categories.
Okay, so you do survey and you get a chart of how many Asian people, how many Hispanic people, whatever. This actually is a example of the data that you collect, okay? And then the total number of the people that you pick is called the N number, how many people, how many sample that you collect, okay?
And on the left-hand side. Or a different way to collect data besides a bar graph would be something like a pie chart.
Pie chart,
so this
yeah.
is where they collect like body mass index for their project. And this is what it looks like.
So this pie chart actually is to categorize it and knowing about the percentage of each category. Is okay?
Then your results could also look like this. This is an example of pre and post test results, very raw data. And they went ahead and put the question on the left-hand side, and then they did 2 columns for pre-test, post-test corrects. As you can see, if you're just quickly glancing at it, you can get an idea that there was a difference, there was a degree of change in the work that they did after their intervention. So for analysis and discussion, you want to ask yourselves, were your project goals and objectives met? Was there an impact? What did you find?
Okay, so when you finish, you collecting the data, and then eventually you need to know, why do I do this study? Do I meet all of the objectives that I was set up? And where is the impact? And what do I find from those data? These are the discussion and analysis you need to make. Is that okay?
Yeah.
Okay.
Was there an impact? What did you find? So interpretation of what the data is telling you, this is kind of gonna be up to your discussion. This is part of the discussion. As a group, you start looking at what, did our program have an effect? And in some cases, it may have a positive effect, it may have negative effect, or it may have no effect. In hindsight, this is very important. I was talking to a lot of groups throughout and saying that it's very important that, once you gather your data and you look at your pre and post test, is what may have affected the outcome. So was there anything that was missing, anything that you would do differently? And did you discover that conclusions can't be drawn because you're missing data that you should have collected? So this is really cool because this is where, now that you've done it all, in hindsight, you think, oh, we should have asked the question this way, or we should have asked this question.
Okay, so you analyze your whole process and you may make multiplication, and you may do survey second time or third time, okay? That actually is keep improving your data quality, okay? So here we don't go through the whole thing because it takes longer times, okay? We just want to give you the basic idea of what the whole process of the data is and how to tell a story in data science, okay? Now we need to move on to the next topic, okay? I don't want to waste too much time here. I want to finish the whole chapter for you today, okay? But this is actually about the second video I sent out about data science and the analysis, okay? Now let's move on to the next one. So you collect data, you analyze it, you actually make a chart, you know how to present it. Next one, we will talk about machine learning. We will not talk about how to find the pattern recognition, okay? So you do study for for it. Next one will be data regression. Okay, what is data regression? Data regression is that we do get a bunch of number here, and we try to analyze this average score like this. So this line, maybe let's assume that this one is GPA times 800 plus SAT equals 1400. Okay, so there's a line GPA, so this is GPA. This X is GPA, this S is SAT. So you want to know about the distribution of the data. So from a lot of this data here, okay, to the line, you come up with this equation. The process of from the data sample to line, we call it regression. Is that okay? From
Yeah.
data to the mathematical model, we call it regression. Okay? From data to model, we call it regression. So why we want to build model? Because we want to use it for machine learning. So let's go back to the chart that actually in the very beginning we talk about here. We talk about data science. You clean the data, you put it into the analysis, then you build a mathematical model. So this part is regression. You come out with equation, so you become ax plus by greater equals 300. Those mathematical model is your statistical model that you want to build up. Is that okay?
Yeah.
And well, the number of the AS plus BY plus CG plus DW, this different called weight and parameter. Each one of them, we call it a token. So right now, the AI model, the Group 5 AI model, they will be over 5 trillion tokens. So the model becomes so complicated. The variable is so many. Okay, is that okay?
Yeah.
Okay, that's what we talk about right here. That what is the AI? So you need to know about what is regression. You try to summarize what equation or mathematical what it is. Okay, so you got do your trading data for your stock is that this. You keep doing this. So you get to go to do 5-day average. Then you got a red line, and this is one mathematical model. You tell people the trend of the stock because your trading data is so shaky, you cannot tell people the trend. But if you got the red line, you can say that it's going this way or going this way, right? Is that okay?
Yeah.
So you need to build a mathematical model, do regression, and you will actually be able to get it. So that's why regression analysis is very important. And regression analysis is part of the statistics. Okay, you learn statistics. One of the reasons you do that is for for finding out the equation for the mass. So then we know there's regression. There's number is NO is number of independent variables. So it's XYZ. How many XYZ? Okay, and there's a type of dependent variable. It is okay. And it's a shape of the line. It may be is AX plus BY, or it may be AX squared plus BY. That's the shape of the regression line. Is that okay so far?
Yeah.
Okay, so that's the core regression technique. And then we have linear regression because the line, if it's AX plus BY, we call it linear regression. We may have logistic regression if actually A log X plus B log Y, okay, equals 3. This is called logistic. And you may be polynomial, maybe stable function. So there are a lot of different mathematical function to model it. Okay. So there is a linear and nonlinear. Using the linear XYZ is called linear. Nonlinear means use a x square or maybe log x. Those are nonlinear. Okay, so it's simple one variable model, multiple variable model. Okay, there's different regression model. Okay, so you may have data like that. You may come up with one variable ax y equal ax plus b, and then your data doesn't actually fit it. So this is underfit. Okay, you may have too many variables. You actually ax cubed plus bx2 plus cx plus d plus equals y. So you have many curves, but this one may be overfitting. Overfitting means you use too many variables or too many order. So this is just right. This may be quadratic equation. Ax squared plus b equals y. Then this line is good. That's called just right fitting. So you may have overfitting. It means you use too many higher degree, or you actually underfitted. Your degree is not enough. Is that okay?
Yeah.
So math sometimes may overfitting it, may underfitting it. So you need to change the model. So AI's data science, the number one thing is to find data model. And nowadays we use the LLM, large language model. That means you have trillions of tokens to help you to do it. Usually more token, your fitting will be more accurate. Okay. So this is linear regression, but this linear regression is a outlier. There's a data that is totally not according to the line. Otherwise, this regular part, they are staying around this equation, y equals 0.2811 x plus 13.9. Is that okay?
Yeah.
Okay, but this one outline, if we take out this line, is okay. That's called linear regression. Try to create a line that closely matching it. But this one is linear because it's the first order model. You may also have a local function. Then it's a or logistic regression using local function, or you may use a polynomial function, quadratic in this case, to curve fit it. Okay. And then you may use a stepwise function or many different functions to do it. Okay. So these are different functions to do regression. We don't cover everything. This actually belongs to the statistics course. Okay. This belongs to statistics course. Our purpose is to do data science and do programming. So you have two research methods, quantitative research and qualitative research. We already talked about it. Okay. It's okay. The next one is machine learning. Machine learning is use the past data to build your mathematical model. Okay, that's called machine learning. Okay, let's look at what is machine learning.
My name is Ale Flores, and I'm a product manager at Alexa. My name is Dr. Chelsea Haupt. I work at the Allen Institute for Artificial Intelligence, and I work on an AI-powered academic search engine. All around you, computers are making decisions, and those decisions affect your daily life. When you do an internet search or scroll through your newsfeed, computers decide what you see. Computers can already recognize your face and understand your voice. And soon they'll be driving cars and detecting diseases even better than humans. So how is any of this possible?
You may have heard about something called AI, or artificial intelligence. True artificial intelligence is decades away. There's a type of AI called machine learning that is here today. It's a type of AI you probably interact with every day without even knowing it. And it has the opportunity to help us tackle some of the world's biggest challenges.
Okay, so machine learning, the purpose of this, you look at it, it may be used to do video recommendation, voice recognition. You say something and they try to translate the language to the other. And then digital assistant try to come up with the travel itinerary for you. Okay, so these are different purpose for machine learning.
To tackle some of the world's biggest challenges.
Machine learning is how computers recognize patterns and make decisions without being explicitly programmed. What's so exciting?
Okay, making pattern means that you have a lot of score, and then you come up with the equation. That's a simple equation like this. This is AX squared plus BY equal 4. That's assuming this is a line. Then you come up with the conclusion that this is a line. This is called pattern recognition because you recognize and regression it into a line. And then you use this line to predict what the score should be. Is that okay?
Yeah.
If somebody use that to ask you where this one should be, your real data is the red one, but your predicted one is the green one. Is that okay? Because when you get different X, some people ask, oh, you get this much X, what kind of Y you should get? Okay. So you based on a mathematical model to answer the question.
Is that it's a completely different way to program a computer than what we've ever done before. With machine learning, instead of programming a computer step by step, you can program a computer to learn just like you learn, through trial and error and lots of practice.
Learning comes from experience, and that's true for machine learning too. In this case, experience means lots and lots of data. Machine learning can take in any kind of data, images, video, audio, or text.
Okay, give you an example for machine learning is that you do handwriting, so you write this way. How could I know this is 3 or this is 8? So you keep giving them a lot of writing. So somebody write this way, somebody write this way, somebody may write this way. Okay, whatever way you use them for the AI to learn, these are the way people may write 3. So keep learning it, and then one day you get them the writing like this, and they will determine this is not a 3. So you pick it up or you disqualified it, it actually is based on your past experience of what data you have. So you keep training the model, and then the model learn that, oh, the way that we have, if you want to have a 3, then you must have one part here, one part here, one part here. You must have 3 sections here, here, here. Is that okay?
Yeah.
And this one is 1, 2. So this one is wrong. This is not a 3. Okay? This is not a 3. So based on past data to learn it and use a mathematical model to model it, and the input can be image, can be video, can be audio, can be text, all kind of things, depending on your model, because machine learning there's no limit.
And begin to recognize patterns in that data. Once it learns to recognize patterns in the data, it can also learn to make predictions based on those patterns, like noticing the difference between an image of a car and an image of a bicycle.
AI and machine learning are playing a bigger and bigger role in society at large, shaping all of our futures. That's why it's so important to learn how it works with some hands-on experience. Remember, AI is like any tool. First you get the knowledge, then you get the power.
Okay, so this one is a quick introduction for what is AI and machine learning, okay? Okay, so we know that machine learning is based on mathematical model. We collect data and finding the patterns. Okay, and then we do an analysis for it. As for how to do it, you need to take AP calculus, multivariable calculus, you need to take statistics, you need to do programming, you need to learn a lot of things before you can write a program for machine learning, okay? But right here, you just need to know how to use the AI tools. Is that okay? How to use it. To program it is actually much harder, okay? So you have supervised learning or unsupervised learning. So supervised learning is doing regression and classification. Regression is to fit into an equation that I talked about it already. You have many points. You try to fit a data, that's called regression. Classification is that you are given an image. Is it 3 or is it 2? And then give this image, is it 3 or is it 2? This is called classification. Because your answer, you classify to 0 to 9, you actually try to clarify. And there's another category, is none of them. So there is a writing, and then you look at what category it is. And this maybe it determines not none of them because it's alpha, it's not even 2 or 3. So this kind of thing is called classification, to classify, to sort it out what data it is. Is okay?
Yeah.
Okay, unsupervised learning is clustering according to the distance. What does this mean? This means that, okay, this one called clustering means that let's assume that you actually try to study the Fremont City. People who like McDonald's or like KFC, you know KFC, right? Kentucky Fried Chicken.
Yeah.
And McDonald's burger. So these two are fast food. So let's assume that your people is like this. Okay, McDonald people, let me use the red, okay, because McDonald is red and yellow. Okay, let's actually use the red. Okay, this one is McDonald's location. Okay, and then you actually also come. Let me use a green color for KFC. So there are people who prefer KFC. They live right here, right here. Okay, then now, if you give me a data of a person live in here, I will determine whether he like KFC more or like McDonald's more. So before I do that, actually, I need to group my data of my KFC and my McDonald's. Okay, let's assume that we actually do clustering like this. Based on that, we actually come up with a division line. So this division line come up. Okay, let's assume that I actually divide it into here. So this portion belong to KFC. The unselected part belong to McDonald. So based on this, if you ask me certain person in certain region, I would say like more likely he's like KFC than McDonald. This kind of the AI, we call it clustering, grouping the data according to the distance. Is that okay?
Yeah.
So regression is matching a line. Classification is to categorize them. Is it a cat? Is it a dog? Those kind of things called classification. Grouping the data to the shorter distance like KFC or McDonald's, that is called clustering. These are 3 major type of machine learning so far. Okay. And then there's another one called association. Find the frequency occurrence. So for example, I do look at A to Z distribution, how many A happen. So I would know what is the probability of A to Z happen. Okay, that's called association. And there's a legal prediction, but the majority of those three types are these three types. Okay, these are more important types. Okay, whatever. So regression, for example, like you have a black and white, you try to restore them into color. So you originally have the black and white data, and you actually try to get your RGB value, predict the RGB value to restore the color. Is that okay?
Yeah.
That's called regression. And this actually is using the equation. Okay, using the equation. So that equation, we call it regression. You classify it is a dog or is a cat. It's called classification. Okay. And then this we call it reinforcement training because you can train it to the AI tool to break the block destroying game. Okay. And then your prediction, your clustering, okay, where the crime rate is higher using K-mean, it's called K-mean clustering. Okay. That's also used for determining a region preferring McDonald's or KFC. Okay. Okay, AI is used in a college application or science, okay, right now. So you come up with the equation, that's called regression, okay. Okay, and there are some issue about AI, okay. This one I'll go faster, we may end here, okay. Today we may end here because we run out of time, but basically telling you the very, very basic of what is the AI and machine learning, okay. But it's not so easy. If you really study it, it's still a long way to go, okay? We just give you what are the tools, what you want to do, and what's the purpose, and tell you the basic idea, okay? That's the basic part you need to learn so far, okay? Other things, I think, over 15, under 15, up to more, okay, to classify them, okay? K-mean classify. There are many techniques in statistics, okay, to do that. Okay, this portion I think too far. And then convolution, so detecting this one to be this. So this is a 5. Okay, using neural network to detect it, okay? To detect the component of this, and this. Is okay? Or 3, if you 3 should be here, here, here. 3 group. Then we consider it actually is a 3. This 5 is in here, here, here. It's okay so far?
Yeah.
Trying to, this is classification, okay? Okay, that's about it. And then large language model. Large language model means that you use a mathematical model that use thousands of trillions of tokens. So a lot of X, Y, Z, W, whatever, put it into the machine to predict something. We call it LLM, okay, large language model. So large language model right here, there are a lot of companies come out with the large language. This one may be a little bit older now already, but some of them used for text generation. This is Gen AI. Some use them for classification. Some of them used for translation. Some of them used for dialogue, Q&A section, chatbot. Okay, so these are different from LM model to do everything. Okay, this is what AI is nowadays. Okay, and the key point is that you want to do data storytelling. As a key part, you do analysis. Okay, you want to tell a story, tell people to buy stock or sell stock. Okay, that's the pure storytelling. Okay, today we go through what is data, what is data science, what is machine learning, give you the idea of how to do data mining to extract data from data to information to knowledge to wisdom. Is that okay? And we talk about the idea concept that good enough for you to take the exam, but in terms of how to write them in programs, I think it will take several years to learn. Okay, it's not just one lesson that can teach you everything. Okay. Any questions so far?
No.
No, that's it for today. Okay. Good night and bye bye. Bye bye.